Good morning, ma'am. This is Tirthika, EC department. Today's my topic name is Problem on Mesh Analysis of Sinusoidal Responses. Introduction to mesh analysis. Mesh analysis is a method used to analyze electrical circuits using Kirchhoff voltage law. It simplifies the process of finding currents in each loop of a circuit. This technique is particularly effective for circuits with sinusoidal sources. Basics of sinusoidal responses. A sinusoidal response refers to how circuit elements react to sinusoidal voltage or current inputs. The response can be characterized by amplitude, phase, and frequency. Understanding sinusoidal response is crucial for analyzing alternating current circuits. Here there is graph. Sinusoidal response graph. For applying mesh analysis, in mesh analysis we define mesh currents for each independent loops in the circuit. Using Kirchhoff voltage law, we write equation based on the sum of voltage drops and rises around each mesh. The sinusoidal sources are represented as phasors to simplify calculations. Phasor representation. Phasor converts sinusoidal time function into complex numbers for easier manipulation. The magnitude and phase angle of sinusoidal function are represented in the phasor domain. This representation helps in solving mesh equations involving sinusoidal sources. Formulating mesh equations. Each mesh equation includes terms for resistive, inductive, and capacitive elements also. And inductors and capacitors introduce complex impedance that must be accounted for. The resulting equations can be solved using algebraic methods or matrix techniques. Solving the mesh equations. Once the mesh equations are formulated, they can be solved for mesh currents. Techniques like substitution or matrix inversion may be used for solving systems of equation for mesh equations. The solutions provide for the currents flowing through each loop in the circuit. Calculating voltages and circuits. From the mesh currents, we can calculate the voltages across each circuit element. The current through individual components can also be derived from the mesh currents. This information is critical for understanding the circuit's behavior. Example problem. Consider a circuit with two meshes and sinusoidal voltage sources. Next, we will define mesh currents, current I1 and current I2 for each loop. The goal is to derive the mesh equation based on the circuit elements and sources. Example problem solution. Step 1 is after formulating the mesh equation, we solve for current I1 and current I2. The results will give us the currents in terms of phasors, which can be converted back to time of domain. The final step involves checking the result against expected circuit behavior. For example, there is to determine the circuit along 5 ohm resistor for a given circuit. In given circuit, there is a two loops. For step 1, applying on the Kirchhoff voltage law equation. For loop 1, there is a minus 5 I1 minus 3 I1 minus 4 I1 plus 4 I2 plus 10 equation is equals to 0. For loop 1, we take it. And the substitute minus 12 I1 plus 4 I2 equals to minus 10. This is a equation 1. And loop 2 also take loop 2 circuit for applying KVL equation for both equation 1 and equation 2. Minus 4 I2 minus 3 I2 minus 1 I2 plus 4 I1 equals to 0 for loop 2 circuit. And we substitute minus 8 I2 plus 4 I1 equals to 0. This is equation 2. From equation 1 and 2, we substitute minus 20 I2 equals to minus 10. I2 equals to 1 by 2. I2 equals to 1 by 2 means 0.5 amperes. From second equation, minus 8 I2 plus 4 I1 equals to 0. We substitute I2 equation in equation 2. Minus 8 into 1 by 2 plus 4i1 equals to 0. Minus 4 plus 4i1 equals to 0. Minus 4 this side comes plus 4. 4i1 equals to 4. I1 equals to 4 by 4. I1 equals to 1. So I1 minus I2 equals to 1 minus 0.5. Answer 0.5 amperes. Conclusion. Mesh analysis is powerful tool for analyzing alternating current circuits with sinusoidal inputs. Mastery of this technique allows engineers to design and troubleshoot complex circuits effectively. Understanding sinusoidal response through mesh analysis is essential in electrical engineering. Thank you for giving this opportunity, ma'am.